Hello folks, this is ActorDev, and on this video I want to give you an overview that's about something that always fascinated me. It's about actor model. So actor model was invented a long time ago. It's a way to develop system. It's a model to develop system that allow you to create a resilience um, software, fault tolerant, and high distributed. Basically everything that we need today. So let's start. On actor model, you can think everything is actor. You can make a small parallel with object-oriented object programming, where you have or everything's a object, and on actor model, everything's a model. It's an actor. Sorry. So let's start. So here you're going to have an actor A here, actor A, and we can have also another actor B and actor C here. And actor C. Actor C and an actor B here. So how they will communicate between them? So they are going to have something called they call reference. So actor A can call actor B via reference, and actor A can call actor C via reference, and the same as actor B to actor C. So you can have this reference here, and if you need, you can have this also. For example, if you need to give back the communication actor A, so you're going to have this reference. And you can think each actor is going to be threads or virtual threads or a Golang, Go routine or something that allow you to run this actor in parallel. So in concurrence model. So they are going to be run independently each other. And another interesting stuff, it's they have something called local transparency. So here you can be running in node A, and you can be also running this on node B here, for example. Node B. And yeah, that's nice. So when you are running an actor model, even you have this reference, you are not going to call, let's say you have a method here to do something, you're not going to actor A call actor B here. You're going to pass this through a message. So it actors communicate between them, passing a message, and this message should be serializable, and it may be or not be passed through network. So, for example, on here, on actor B, when you want to communicate with actor C, it's going to be here. It can be or not serializable, depending on the case, on the framework. Sometimes yes, sometimes not. But it's not going to use the network. But when actor A wants to communicate with actor B, it's definitely going to pass through network, and it's going to be serializable. So yeah, so that is the main concept about actor model. So have local transparency, message between actors, each actor run independently, and yeah, and message can be passed through network. Another nice nice thing about actor model, it's you have here something called mailbox. So actor AA, and here you have actor B. So this communication, like I said, it's not directly. You're going to have something called messages, and actor B is not going to consume a message directly. He's going to consume it through your own mailbox. So each actor has your own mailbox here. So you go to mailbox for actor B, for example. So A is going to send a message to this mailbox, and this mailbox here, it's going to be read only by actor B. So you're going to have like many messages here, and actor B is going to read this one here and throw away. Then he's going to read this one here and throw away. and you can have like this, something like this. Actor A and actor C send a message to actor B here. So both are send message to actor B through this through this mailbox. Normally, you implement this mailbox as FIFO, first in, first out. But there are some cases where you don't want to do this. There are some cases you want like have some priority. Let's say actor C posts a message that should be processed first. So came here because of your mailbox algorithm. It's going to be in the first. So while it's processing this message was sent, get priority, finish process this message, and the next message is going to pick up is going to be this one. So another thing that's interesting they have it's about concept about private state. So each actor has their own private state here, as you can see. So this actor can change this state here, and only actor B can change your own state. You cannot have something like this came here, I want to change. No, this is not permitted, and and if you want to change anything, you need to do through message. And another thing they have, it's something called behavior. So when you are processing a message, you finish it, it's going to discard, and you can change the behavior of this actor. So the next message is going to process is going to be a different behavior. So you can think of this behavior as a state machine. You process something, make a change, go to the next state, do another thing, go to the next state, or go back, so depends. And for last core concept you have on actor model, it's something called supervisor. So let's go here, supervisor. What is a supervisor? Let's imagine you have an actor here, an actor A again, and this actor here, he misbehavior. So what do you do when a child misbehavior? You're going to talk to your parents. It's the same on actor model here. So let's say you have these three actors that belong to supervisor, to this supervisor. So here. So the supervisor is responsible for these three actors. Yeah. So what happened if if a fail here? There's like a failure, can be anything. It's going to report to your parent about this failure, so to your supervisor, and the supervisor is going to decide what to do. He can decide to kill this one and start a new actor, B for example, to get the job of what actor A was doing. For example, here C, D, actor D, and here. And it's going to get the message that actor A was doing. This is called 1 for 1. So if one fail, I'm going to drop this one and restart. Or let's say actor B failed now. What actor B was doing, it needs to be processed like in this block here, and the supervisor can decide, no, I'm going to kill everyone, and restart again all process, but now calling this as here actor E, F, and G. This is what we call all for one. So if one fail, the supervisor can decide to restart everyone again. Yeah. Also, a supervisor can be supervisor by another supervisor. So you can think like this as a tree. So one supervisor can have or not a parent, supervisor, and yeah, select this supervisor 1, and here let's call root supervisor. Supervisor, and let's say e fail. So if this fail here, he can send a message to your parent, so to your own supervisor, saying, hey, I had a failure, what I should do. Supervisor can say, I don't know what to do. I need to go to my supervisor to say. And the supervisor can decide to restart the whole tree, ask on to restart this actor, start all supervisors, and so on. On actor models, normally all actors are a supervisor, but not all supervisors are actors. So depend on the case and on the framework, but you can have this concept. These are the core concept for actor models. So it's very interesting and you can do a lot of things. Yeah, but there's another cool concept that's not part of this core here. It's something that Microsoft has developed a few years ago that is they call virtual actor models. So let's imagine you have here node A, then we have here a node B, node. Now you create for any reason you decide to create an actor here, or let's call this actor, and you need to communicate with an actor that represent and that represent the ID1. So let's say you are working with DDD. Let's use actor model and decide each actor is going to be one domain, one aggregate root. Okay, so that's nice because each one can run parallel. I won't need to care about locking because of this mailbox. So everything's nice. So this seems to be fit very well. But now you have this here. You are actor A and you need to communicate with an actor that's going to represent a user, for example. Let's say here, actor B, user 1, for example. So how do you know this actor is here? How you communicate with this here? You should have the property here. So basically you need to have a way to have a map between all actors that you have on node B and which domain they represent of each user. And if it not exists, you should create it and you should keep this list sync. With 2 nodes, maybe it's easy. Let's imagine you have 100 nodes, how you're going to do it. It's going to be very, very difficult to keep this list sync. Yeah, guarantee everything's working. So that's why Microsoft created this called virtual actor model. So let's say here, let's call this framework. Okay. So we can call this, for example, framework. So the framework is going to decide to you. So here on virtual your actor A, you're going to say here, I want to send this message here to the virtual to user 1. To user 1. User 1. I want to send this message to user 1. And the framework is going to look, okay, let's see where this is one. So based on any algorithm that you want to have, like hashing or fixed nodes, whatever, so it can have different algorithms, it's going to say, I know this user should be at node B, and let's say it's already exists here. So he's going to get this one for you, and send to this actor here. Let's say now we want to send to this to user 2, but this user 2 doesn't exist, but you still want doesn't exist, and it should be on node B again. So the framework that we are using is going to do this work for you. So he's going to create a new actor for you. It's going to be actor C. It represents user 2, and the framework is going to take care for you to do this. So he's going to create this one, grab this one, do here. Let's say now for any reason you need to scale and you need to have a node C here. So let's see, node C. He's going to say, okay, now we have to rebalance here. And I came at the decision that actor should not live here, should be moved to actor B, to node C. So the framework is going to do this for you. Yeah, he's going to move this actor to here and ensure that whatever, when we need this, is going to come here and ensure that this is going to be here. And to access this actor, you are not going to use reference now. Now you're going to use the identifier. So this identifier is going to do this work for you. And this framework who's going to take care of actor life cycle. He's going to decide when this actor should be up, when this actor should be down. So the framework is going to decide if you. So advantage is for us as developer, we have less work overhead how to manage this actor. For many cases, it's very useful. For example, for event sourcing and DDD. But it have you less flexibility when you came here and say, I want to create this one. What will happen? Yeah, okay. So you won't have this direct reference. You can, but you won't have this directly. But yeah, it's very nice concept. This is how Microsoft Orleans has implemented this virtual actor model. If you are interested, you can take a look if your program language has this concept. In .NET we have, for example, Proto framework is who has this concept, this both concept here, the classic actor model and this virtual actor model. But I know like .NET framework only have this classic, let's say. But yeah, so you need to check what makes sense for you. So this is for today. Think about next videos, do some videos about how to do this actor model using some framework. And if you're interested, please take a read, see other frameworks. Take a look also at Elixir framework, Elixir programming language, because it's based on actor model and it is very interesting.